Okay, so homework 2, Part B. We're asked using a force balance on a rectangular prism, demonstrate the buoyant force is equal to the weight of the fluid displaced. Explain how this extends to an arbitrary shaped object, for example, a human body. So right here, I already have it drawn out, or else this would have taken like 5 minutes. So we have a rectangular prism and some fluid. We'll just call it water. Then we have the height of the height of this rectangular prism. Then we have the height from the water to the top surface of this rectangular prism, then which is h, and then the height of this is height of the prism, just big H. And then the depth of how far down this rectangular prism goes is just h, little h plus big H. It's right there. Then we have the area of this top surface. We just have the area. We have the density of this rectangular prism, then the density of the fluid. So there will be a pressure force, be a force going up on this rectangular prism object. And there's also a pressure force going down. All right, and then to find this pressure force at the bottom, so P H plus big H is equal to the density of the fluid, let's call it water. So density of the water times gravity times the depth that we're at, which is just H plus big H. All right. So to find this force, since there's a force going up, we need to find what this force is. So the force acting up on the rectangular prism, force acting up at H plus big H is equal to the density of water times gravity still times the depth we're at, H plus big H. You multiply that by the area. So that's the force acting up on the bottom of this rectangular prism. And let's find the force acting down at the top of this rectangular prism at height of H, just a little h. That is equal to the density of water still times gravity. And since we're not at the bottom, we're at the top surface, we're just multiplying it by a little h, multiplying that by A. So you can see here, the only difference is the depth of where we're finding this force is at. So see that this is just H for the force acting down, and at the bottom is it's the whole distance, the whole depth of H plus H. So we can find the net pressure force. The net pressure, just put net P, is equal to density of the fluid, which we have named water, times gravity. And you can cancel this H and H, so it's just big H times area. And what height times area is, that's just the volume. That's just the volume of this rectangular prism times the density of the fluid times the gravity. Next, explain how this extends to an arbitrary shaped object like a human body. So let's just say like you can take like human body and just like not literally slice it up, but slice it up in like these rectangular pieces like this. Do the same equation and then just like add up all of like what you get the weight of the fluid displaced. Add up all those, and that will give you the buoyant force.